All right. So welcome for this lesson. We are doing statistics 1. We're doing statistics 1. Yeah, thank you. Thank you for joining. So we're going to discuss statistics. We are told the table below shows the length of 40 seedlings. 40 seedlings, length in millimeters, and the frequency, or rather the number of seedlings having a given length. Then we are told to determine part 1, the modal class. It should be noted that modal class is the class with highest frequency. This is the class with highest frequency. Class with highest frequency. Class with highest frequency. So when we examine this data, we discover that the highest frequency is 12. The frequency itself is called the modal frequency, and now the class having such a frequency is called the modal class. So our modal class is 145 to 153. 145 to 153. Thus, this gives you a mark now for identifying the class with the highest frequency. Thank you for joining. You can also share with a friend. Okay, the median class. This is the class which carries the median height. And this is how we identify the median class. First of all, we come up with what we call the cumulative frequencies for the given data. Cumulative frequencies for the given data. Cumulative frequencies. Therefore, I can call it CF, cumulative frequencies. So the first frequency is 3. I add to the next, which is a 4, so I get 7. I add to the next, which is 10. This gives us 17. I add to the next, which is 12, for a 29. I add to the next, which are 5, for a 34. I add to 4, 38. Then finally 40. So these are what we call cumulative frequencies. Now for me to identify median class, I'll need to get the total frequency, which is 40. Let me use this space. And I divide by 2. 40 divided by 2 gives me 20. Now, the 20th seedling is the median one. The 20th seedling is the median one. Therefore, I'll look for the class that accommodates 20th seedling. And that class is going to be, in the first class, there are only 3. When I add to the second, there are only 7. So 20th is yet. In the third one, there are only 17. But now, where we have 29, because before this 29, there was only 17. So it means the 20th seedling is in this class. And coincidentally, the class which is having our median is the class 145 to 153. 145 to 153. So coincidentally, the median class is also the modal class, coincidentally. So don't think that the median class is also the modal class. It is only in this scenario whereby the class is proving to be the same. How are you getting these cumulative frequencies? Somebody is asking me, and I will respond to that. How I'm getting cumulative frequencies is that I'm just accumulating or adding up all the frequencies. So we start with 3, it's the first one in that class. Then the second one becomes 3 plus the next frequency, which is a 4. So I get 7. 7 plus the next, which is a 10. So I get 17. 17 plus the next, which is 12, 29, and such until I get 40. So that is how we get cumulative frequencies. Abdullah. So make sure you follow. Okay, we are told to get the mean of the seedlings. The mean of the seedlings. And how do we get the mean? So mean is usually given by the summation of f multiplied by x divided by the summation of f. In this case, you should know that f is the frequencies and x is the midpoint of the classes. So x is the midpoints of these classes. X is the respective midpoints for the several classes. So I can come up with a column of the midpoints for the classes. And for me to get a midpoint of a class, I need to add the limits and I divide by 2. 118 plus 126, then I divide by 2. This gives me 122. So this is x, the midpoints, 122. Then I multiply 122. For me to get f of x now, fx, I will need the product of frequency and the midpoints. So I multiply by 3. This gives me 366. The next will be 127 plus 135. Then I divide by 2 and this gives me 131. 131. That was 127 plus 135. Then I divide by 2. 131. Then I multiply with the frequency there, which is 4. This gives me 524. 524. The next is going to be, the midpoint is going to be 136 plus 144. Then I divide by 2. This gives me 140. 140. Then I multiply 140 by the frequency here, which is 10, to give me 1400. Then I go to the next class, whereby the midpoint is going to be 145 plus 153. This gives me, when I divide by 2, 149. So I'll multiply 149 with the frequency here, which is 12. This gives me 1788. Then I'll go to the next, which is 154 plus 162. Then I divide by 2, 158. Then 158 by the frequency here, which is 5. I'm going to have 790. 790. Then I'll go to 163 plus 171 and I divide by 2. I get 167. 167 multiplied by the frequency here, which is 4. This is 668. 668. Then finally, I'll get the midpoint by taking 172 plus 180. Then I divide by 2. 172 plus 180 divided by 2. This gives me 176. Then I multiply with the frequency here of 2. This gives me 352. 352. Therefore, now I can get the summation. I can get the summation of all the f of x now. Summation of f of x by adding all the values. This is going to give me, when I take 366 plus 524 plus 1400 plus 1788 plus 790 plus 668 plus 352. This is giving me 5888. 5888. Somebody telling me that we cannot see well. I'm trying my best to focus whatever is happening on the bench. Kindly tilt your gadget so that you may understand what is happening. I'm trying to have enough light. So now I'm going to apply the formulae for mean. And in this case, I'll have 5888 divided by the summation of f, which is 40. This is going to give us, when I divide by 40, 147.2. 147.2 as the median, as the mean, sorry. Then we get now to median. Then we get to median, and we say that we can get the formula for median. Median is given by L plus N out of 2 minus CFB divided by frequency. Then this one is multiplied by the class width. Let me define each variable in the given formula. L is the lower class boundary of the median class, so we can substitute it. Lower class boundary of the median class. The median class has already been identified in a process up here. So this is the median class. We need the lower class boundary when the limit is 145. So the lower limit is 145, which means the lower boundary is 144.5. 144.5. So 144.5 plus N is total frequency divided by 2. So total frequency of 40 divided by 2. Then I subtract CFB. This is the cumulative frequency before this median class. So cumulative frequencies are here. And before the median class, we have 17. So cumulative frequency before the median class is 17. So I'll have 17 there. Then I will divide by frequency of the median class, which is 12. Frequency of the median class is 12. Then I multiply by what we call the class width. It is good to know that class width is usually given by upper class boundary minus lower class boundary. Therefore, a upper class boundary of 153.5 and a lower boundary of 144.5. So this is going to give us exactly 9. So the class width is going to be 9. Class width is going to be 9. Therefore, we can work out now. 40 divided by 2 is 20. So 20 minus 17 giving us 3. We divide by 12 giving us 0.25. We multiply by 9 giving us 2.25. Then we add 144.5. This will give us exactly 146.75. This is the exact value of the median in this case. So I can show you now a different question on the same. But remember, tomorrow we're going to cover statistics 2. Tomorrow we shall have statistics 2. Another question here is telling us that the figure below shows the marks obtained by 60 students in a test. So we have the marks there in classes and the number of students who scored the respective marks. Then we are told to calculate, first of all, the mean mark. To calculate the mean mark. This means for us to calculate the mean mark, then we will need a table. We need a table of all the midpoints. X, then the product of each midpoints and the frequency. So the first midpoint is going to be between 10 and 19. 10 and 19. This gives us 14.5. So I'll multiply 14 by 5, 0.5 by 2 to give me 29. The next midpoint is going to be between 20 and 29. So when I divide by 2, I'm getting 24.5. So I multiply with the frequency there, which is also 2. So I multiply by 2. This gives me 49. The next is going to be 30 and 39. So I'll get 34.5, and I'll multiply it with 3. 34.5 by 3. This gives us 103.5. The next will be between 40 and 49, which is 44.5. 44.5. Then I multiply that by 8. This gives us 356. 356. The next is between 50 and 59. That is going to be 54.5. 54.5. So I'll multiply this by 23. 54.5 by 23. This gives us 1253. 1253.5. Then the next is going to be between 60 and 69, which will be 64.5. So now 64.5 should be multiplied by 13. 64.5 by 13. This gives us 838.5. Then after 64.4, the next midpoint is between 70 and 79. So that is at 74.5. Then I'll multiply this by 6. Frequency is 6, so 447. 447. The next is going to be 80 and 89, giving us 84.5. 84.5. So 84.5 I'll multiply with or by a frequency of 2, giving us 169. Then finally 90 and 99. The midpoint will be 94.5 by 1. The frequency there is 1. So it will be 94.5. Therefore, I need to get now the summation of f of x. The summation of f of x. All these values now I add them up. 29 plus 49 plus 103.5 103.5 plus 356 plus 1253.5 plus 838.5 plus 447 plus 169 plus 94.5. So this is giving us 3367. 3367. You can carry out the same addition and confirm our values here. So we're going to get now the mean of all these values, which is given by the summation of f of x divided by the summation of f. So I'll need to use now 3367 out of 60. Out of 60. So when I divide this by 60, I'm going to have 56.12 to 4 significant figures. So this will be the mean max. The next to be calculated, we've been taught to calculate the median. You know, it's good to repeat this formula, whereby median equals to L plus n out of 2 minus cumulative frequency just before the median class divided by frequency. Then now I'll multiply this by the class length of the median class. So now we can identify median class, whereby we first of all need to come up with what we call cumulative frequencies. So on this we can get cumulative frequencies, whereby we'll start with 2, then we add 2 to get 4, then we add 3 to get 7, then we add 8 to get 15, then we add 23 to get 38, then we add 13 to get 51, then we add 6 to get 57. Then we add 2 to get 59. Then we add 1 finally to get 60. These are the cumulative frequencies. CF, the cumulative frequencies. Now with the cumulative frequencies, we can take 60, which is the total. We divide by 2 to get 30. So the 30th student is the one who has the median mark, the 30th student. So we're going to identify the class which accommodates the 30th student. In the first one, we don't have 30. After adding, we don't have 30. After adding, we don't have 30. After adding, we are yet to arrive at 30. But now in this class, you can see the 30th student is accommodated here. Therefore, the class 50 to 59 becomes our median class. 50 to 59 becomes our median class. So now with this median class, we can get to the formula now, whereby we will substitute now the lower class boundary, which will be 49.5. 49.5. So this will be 49.5. Then I add, n is total frequency out of 2. So that will be 60 out of 2. Then I subtract cumulative frequency before. The cumulative frequency just before this median class, and the cumulative frequency before the median class. Cumulative frequency at the median class is 38. So just before, we got a 15. So we subtract 15. Subtract 15. Then we divide by f, frequency of the median class, which is 23. Then we multiply by class width. From 49.5, the lower boundary, all the way to 59.5, the upper boundary, we're going to have 10 as the class width. Then now I can work out this. Whereby I will need 60 over 2 giving me 30. Then I subtract 15, remaining with 60 over 2 giving me 30. Then I subtract 15, remaining with 15. Then I divide by 23. Then I multiply by 10. Then I add 49.5. This gives me 56.02. This is the mean. The mean mark for those students who did the given test. We are also told to state the model class. This is the class with the highest frequency, and we've seen that the class with the highest frequency, when we compare all these frequencies, the highest frequency is 23. So the class with such a frequency is called the model class, and it is the class 50 to 59. 50 to 59. 50 to 59. That is our model class. Finally, we are told to represent the information on a histogram. It should be noted that for a histogram, we usually plot what we call frequencies against class boundaries. So when you go to your graphical page and you plot frequencies against class boundaries, you are going to get a histogram. This is for a special case where the class widths are uniform, like in our case here. We have the class widths being 10, all of them. In case class widths vary, then you are going to plot what we call frequency density with different class widths. Frequency density against class boundaries. So thank you for following. Subscribe and share to friends. Thank you.